This is the last clip for tissues, and we're going to just talk a little bit more about the different types of tissues. So the first one we're going to talk about is dense connective tissue. So in dense connective tissue, there's lots of collagen. So remember, collagen makes things stronger versus stretchy. There is some elastin, but it's not as predominant. And so this is the type that can withstand pulling forces and helps in binding our body parts together. So tendons. So remember, tendons connect muscles to bone versus ligaments, which connect bone to bone. Just a picture there to look at the structure of it. Adipose tissue is a type of loose connective tissue, and what it does is it stores fat in the cytoplasm of these cells. So we know that from everybody's body, we store fat differently. We do store fat. Men tend to store it a little bit more around their abdomen and thighs, while women in their arms and their buttock area, of course, their breast tissue and their abdomen as well. So, and some of us have more storage spots than others. What happens is these cells can get enlarged because we're storing this in the cytoplasm fat because we don't know if we need it for energy. And so, of course, there's lots of adipose cells around our body. We find them beneath our skin, between our muscles, kidney, eyeball, surface of our heart. Those are all good areas for it to be in a small amount for protection. Just showing you there there's the cell, there's the nucleus of the cell here, and this is the storage, cytoplasm storage. Cartilage cells, or the term chondrocytes, chondro refers to cartilage, cyte refers to cell, is rigid. And okay, so think in your mind, now imagine that there's you've got a chicken breast and it's still on the bone, and or the turkey breast, and you can see that sort of cartilage type white milk glass kind of look to it that comes down the center. That's one example of cartilage. And cartilage, what it does is it creates, it supports our body parts as they're put together and creates some structure in the framework. So for example, the end of your nose, you can wiggle it around. That's cartilage. Your ear, cartilage. There are 3 different types: hyaline, elastin, and fibrocartilage. Some pictures of cartilage cells. So hyaline has lots of collagen, making it very strong. Okay, and that's the one I've just discussed that reminds you of milk glass. So, and it's also plays a major role in bone development. So when babies are being developed, bones will become a cartilage model first, and then we'll develop the bone cells will attach to it and create the bone structure that we know. Elastic cartilage is very flexible. Inside we would have it in our larynx, but our ear is very flexible. Versus fibrocartilage, which is tough, and this is the one that we'd find connecting some bones together, like your intervertebral discs in your back, your symphysis pubis, which is your hip bones at the front, and we also would have some in our knee as well. So 3 types of cartilage that will come up in the lectures to come. So we'll briefly touch about bone and blood. They'll be more expanded upon in those systems when we get to them, the skeletal system and the blood. So bone, of course, you have a picture in your mind what bones are like. You've seen bones, whether it be animal bones, or I don't think you've probably seen a human bone. Most rigid, okay, because when it's creating its matrix, we also deposit mineral salts in it, calcium and phosphorus. And our bones really are like our steel girders of our body. It creates structure. When they're building a bridge, they put a lot of steel reinforcement around the concrete, and that's really how I imagine bones to be, creating the structure. because you can't, if we took your bones out, you kind of would just be balls of cells. You wouldn't have any structure to you. Of course, protection, you think about your rib cage, protecting your heart and lung area. Um, Bones also create an attachment for our muscles because our muscles have to be connected to our bones to allow for movement in the bones. We have to have some sort of machine there to help us. An osteocyte, osteo refers to bone, cyte refers to a mature cell. A blast is a forming cell, okay? An osteocyte is a mature cell. Just some pictures of the structure there. And blood then is a connective tissue as well. In this situation, it's the matrix. I'm just going to go to a picture here. It'll be helpful. So if you look at, if we took a sample of your blood like you see here, and we allowed the cells to settle down to the bottom, then we would have this sort of serum, this yellowish looking fluid. That's what the cells are all suspended in, or what we call plasma. It's the water part of our blood. And that actually is the matrix. And we will suspend then the 3 types of blood cells: red blood cells here, okay, white blood cells, and platelets. There will also be some proteins in there, some soluble proteins that are necessary for blood clotting for us. So that's its connection to connective tissue. Now, this picture is just to show you our different types of blood cells. So don't worry about the depth and the amount of information there. But you can see that we have 5 types of white blood cells here. Okay. And we have a thrombocyte, which is our clotting cells, and then we have a red blood cell. Again, just information to put in perspective for you. Not necessary to know that. That's coming up later. And that's the end of our clips for tissues.